Hello everyone, let's talk about electric field. So we are done with electric force and electrostatics, so let's move on naman to electric field. So the electric field is like a manifestation na unsaon pag-interact sa two charges without even direct contact, 'di ba? So how do they exert a force to each other? Na ang layo lang nila, meaning walang direct contact ng two charges, pero they can exert force to each other. Okay, so unlike ng normal force, so we can always say nga may force dyan because may contact ng dalawang surface, di ba? So yan yung normal force. Tapos, tsaka tension force. Alam naman natin yung tension is naana siya sa kanang mga rope, sa mga sa mga kanang mga PC, di ba? So makita na to ang mga tension force diha. So we can know nga naay force kay tungod naay interaction or naay direct contact sa particles, di ba? Kung maghang ka og weight sa imuhang PC, so you can always stay na ay tension force because na may contact yung mass at saka yung PC, di ba? So mao na ang direct forces. So now sa inyuhang Newton's law of motion, so you are actually gina-introduce kayo sa mga different types of forces, diba? So we can categorize forces into two. So meron tayong direct forces, direct contact forces or the contact force. Then we have the non-contact forces or the field forces. So the example of the contact forces, so maraming example, mga tension, normal force, frictional force. So these are the different types of contact forces. How about yung non-contact forces or mga field forces? So in your mechanics, one of the most common na ginagamit or example for non-contact forces is actually the gravitational force, 'di ba? So gravitational force is actually a field forces. Okay, so wala naman tayong direct contact, wala tayong direct contact sa Earth, but why Earth is actually pulling us towards sa iyang center. So why is that always? Okay, so kung maghulog ka og bato from a 20 meters nga building, so ang bato of course mo adto gina siya sa ground because of the gravitational field which is always attractive. Now for another naman pod na example of field forces which will be tackled on today is the electric force, which is manifested by the electric field. Okay? So your electric field para siyang comparable to gravitational field. So but this time we are talking about charges. Okay? So gravitational field kasi is yung mga neutral objects, yung mga large masses like mga galaxy, yung mga planets. So gravitational forces ang nag-hold sa mga planets together. Okay? So now we are talking about charges. So mga small particles, mga interaction sa mga pinaka molecular level na. Okay? So to explain the why two charges or charges exert force to one another even though there's no direct contact, walang communication, walang connection naman yung dalawa, na you can say nga uy naalagi ni ko naay forces, di ba? So how can we explain to that? By using the field model. Okay, so itong field model, so the field model is actually para siyang alteration of space. Okay, so if magbutang ko og charge in a three-dimensional space, so for example magbutang ko positive charge, so what will happen is i-alter niya yung space around niya. Okay, so i-alter niya yung space at that alteration is actually called a field. Okay, so kana nga field is anywhere in space, kung saan si charge na imong gibutang. Okay, so mukuha na siya kanang mo extend no siya anywhere in space yung field na tinatawag natin. Okay, so that field is actually the instrument or the agent na mag-exert na siya ng force on other charges. For example, if si A ang ipuput ko doon sa ibutang na ko siya sa space, so na-alter ng space niya, 'di ba? So na mayroon na siyang field, hindi ang tawag natin. Then if I put another charge, so the interaction between A and B is dependent on their charges, 'di ba? If same sila ng sign, repulsion, but if different sila ng sign is attractive. So here, because of the field na produce ni A, so yun yung attraction, or yun yung mechanism ng force nila. Okay, mechanism na paano mag-interact yung mga charges. Okay, so here now this one, ito lang yung mga wavy line is just a dramatic visualization. Hindi talaga natin makikita yung field. Okay? So dramatic lang yan. So parang makita nyo lang na merong field sa para makitaan lang ninyo nga na ay field around your charge A. Okay? So kung magputa po kag another charge B, so maotong mo respond to si B tungod sa field ni A. Okay, so depende lang gyapon ang interaction sa sign of the two charges. Okay? So in electric forces, so the space around a charge na gi-alter sa imuhang charge A is actually called the electric field. Okay, same gyapon siya sa gravitational field sa Earth. Okay? So now there are actually two postulates that we have to insert before going to dig deeper about electric field. Now first one is we have a source charge. So unsa man yung mga source charge? So kaning source charge is actually siya ang tig-produce og electric field. Siya ang tig-alter sa space para maka-produce og electric field. Okay? By producing an electric field. Okay, usually denoted na siya as Q1, Q2, Q3 sa itong problem, or simply Q. Okay, mo na siya. Now, another postulate that we have to insert is there is another kind of charge that we are going to use, which is called the test charge. So, unsa man yung mga test charge? So, kani si test charge is actually maoni ang from the word test, siya ang kibali probe nato if magbutang ta og charge ani nga space, unsa naa ba siya interaction, or naa ba siya effect, or naa siya murag mo repel ba siya, or may attract, depende sa imong source charge. Okay, so mao na imuhang test charge, and actually denoted by Q sub naught. So always na siya Q sub naught. So here, if we are going to base it sa atong first slide, so your charge A is actually your source charge, and your charge B is actually your test charge. So ganun lang. So now, so for example, ganito. So if I have here charge Q1, Q2, and Q3, so ito, I have this one. Tapos maglalagay ako ng, so again ha, static tayo ha. So meaning your Q1 and Q2 and Q3 are not moving. So meaning approximately at rest sila. So now, if may arrangement ako ng charge, na ako arrangement ng mga charge, so I will put another charge which is a test charge. So magbutang ko og test charge nga positive, as you can see here. So ang test charge nimo kay any charge ni siya ha. So it doesn't matter kung electron ba siya, na ba siya positive charge, na ba siya two column charge. So wala siya specific na property. So test charge is place lang siya para bait. Okay, para para atong ma-measure ang force nga gina-exert sa source charge. So mao lang na iyahang purpose. Now na ako'y Q1, Q2 and Q3 here. So kung akong iput si Q sub naught, what will happen is these forces kay since these charges kay since na naman siya alteration sa space around them, so they will exert a force on Q sub naught. So your Q1 will exert a force kay they are both positive, so repulsion, so diri. Then your Q2 is attractive, at pasaka siya, and your Q3 is repulsive. Then we have the vector sum of all the forces here. Okay, so now unsa man the relationships sa imong electric field o sa force exerted on the test charge Q sub naught. So actually given by this equation, so E is equal to force on Q sub naught divided by the amount of charge ni Q sub naught. So parang si E is force per unit charge or unit test charge. Okay? So this is only true if we assume that your Q sub naught is very small. Kaya nga naman, because if dili man good ni siya small imong Q sub naught, what will happen is the charges here will ma-disturb siya, di ba? So meaning mo change ang iyang position or mo move siya, kaya ingong tag static lang atong system. Di ba? Static man tong system. So if gamay siya, what will happen is since gamay raman siya nga test charge, gamay ra iyang effect sa arrangement. So meaning, even though mo move si Q1 and Q2 and Q3, but they are, dili siya noticeable, di ba? Dili ta maka-notice nga ni move, kay because it's very minuscule lang siya. Very small distance na yung pagka-move because of the small test charge. Okay? So maunang kailangan na to nga atong test charge are very small. Okay? So based on the relationship that we had, so maatay since electric field is force per unit charge, so therefore the SI unit of electric field is Newton per coulomb. So yan yung unit niya. So let's talk about the source charge. Okay? So your source charge is positive, meaning that the electric field is pointing away from the charge. So meaning that if I have a positive charge, what will happen is the electric field is pointing away. So meaning pa-away siya. Okay? So we can use this one if we have a field point. Okay? So now sa atong problem ang sa electric field, natay 2 points that we have to consider. We have field point tsaka si source point. Now si source point, ito yung a point kung asa na-locate si source charge. So denoted by letter S. Now kani si field point denoted by letter P is the point where you calculated the electric field. Okay? So for example, if na ako'y source charge nga positive, what will happen is at point P, so this is your field point for example, and gusto ko kukunin gusto na ko kuwaon si electric field at this field point P. So kay since imong source charge is positive, so by our rule, the electric field is pointing away from the charge. So away siya. So yun yung ma-produce yung electric field always. Okay, if yung source charge mo is positive. Now if negative naman yung source charge mo, what will happen is electric field is pointing towards the charge. So towards, pag ganyan siya doon, so towards. Now as you can see, electric field na ma-produce at that point is always in the same line of interaction. Kasi just like, because the electric field is proportional to the electric force. So meaning, they must be in the same line of interactions, as you can see here. Okay, so same line sila ng interaction. Same lang din sa force. Okay, so the electric field of a point charge is given by this equation. So if you are going to find the electric field of point Q, so you can use this equation. Now, how can I do the unsa man akong basihan aning equation. Now look at the illustration. Now the field point P is makita ninyo nga na ay Q sub naught. Okay? So Q sub naught is the test charge, di ba? So kung mo na kog test charge, siya ang tig test if unsa ang force nga gina-exert ni source charge at that point, di ba? So usually sa field point diha mag-locate og force exerted by the source charge. Okay, because you know naman the electric field at that point P, so the location of point P diha nimo ibutang si Q sub naught para kabalo ka unsay force niya. Okay, so how to get this expression kanang KQ over R squared asam na gikan? So actually gikan ni siya sa equation nga, so I will just kuan ang akong kuan. So here you can see that kung tan-awon lang ni nato, so we have here, diba, your E produced by your test charge Q is actually equal to force on the test charge Q sub naught divided by Q sub naught. Now according to Coulomb's law, the force exerted by Q sub naught is actually equal to K Q. So may dalawa kayong charge, si source charge at saka si test charge, divided by R squared. So wag muna natin pansinin yung R hat. So say R hat, wag muna natin yung pansinin. So we have Q sub naught. So we can cancel Q sub naught. So therefore the electric field produced by charge Q is actually equal to KQ over R squared R hat. So yan, because of that relationship, we can actually derive the electric field due to a point charge. So ito. So we have KQ over R squared R hat. So because of this equation, so meaning nga this electric field follows the inverse square law. So meaning the electric field is inversely proportional to the square of the distance. So meaning if magpalayo ta sa charge, ang electric field pud niya is magkahinay. If magkaduol ta sa charge, ang electric field niya is magkakusog. So mao nang iyahang mao nang gitawag nga inverse square law. Now your Q, where your Q is the magnitude of the source charge and R is the distance between the Q and the field point, and your R hat is always pointing from S to P. Okay, as you can see here. Now here, so as you can see, ang imuhang field, electric field due to a point charge is independent of a charge. So meaning even though walang test charge, the electric field is actually like intrinsic property na ng point charge mo, ng source charge mo. Okay? So hindi siya dependent sa test charge ha. So unlike sa force, dapat at least kailangan ka ng dalawang charges. Okay? Para ma-calculate mo yung force, 'di ba? But for electric field, you just need one charge because that source charge is dependent on any other charges. So meaning if you have a charge, intrinsic property na niya yung electric field. So naana niya, just like sa mass nato, di ba? Naana nato na property. Okay, so mao na ang electric field. Okay, so always remember nga ang field point, so just like what I said, is actually the location of the test charge. So meaning doon natin ipuput si test charge para makita nato or ma-measure nato pila ang gina-exert na force ni source charge at that point. Okay? So atong ibutang si test charge sa field point. So remember, because of the fact nga electric field is inversely proportional to the distance, square of the distance, so any point sa space, lahi po ang electric field. Okay, so as you can see here, so if I have a field point here, so as you can see, kung magkalayo ko, akong field point, akong electric field at that point is makagamay. So as you can see sa imong vector dire, so gamay siya og arrow because that represents the magnitude of the vector. Now if makaduol ko, what will happen is that magkataas pod ang iyang vector here, the arrow, because this represents the magnitude. So kung magkaduol ka, magkadako or magkakusog ang imong electric field, di ba? So as you can see here, nga sa imong negative Q nga charge, what will happen is that ang imong mga electric field is always pointing towards the source charge. Ito yung source charge mo, tsaka yung mga black dots are the field point. So iba-iba yung mga value ng electric field around the charges. So anywhere in space, iba-iba. Okay, because 1 over r squared kasi inversely proportional to 1 over r squared. Now same lang gyapon sa positive charge. But a positive source charge will always, iyahang electric field is pointing away from the charge, as you can see here. So kung makadulot sa charge, so this one is actually magkadako pud ang iyahang magnitude or the length of the electric field. So makalayo pud ta, makagamay pud. So given by the arrow here, so yung body, so makita nito na gamay lang siya. Now, so I will tell you na at this point na as you can see sa inyong arrow here, they are of the same length. So meaning if we form a circle, butang circle diha, so ang distance sa manggod niya dire are equal, di ba, with respect sa imong negative Q. So therefore, this electric field at these field points are equal. Okay, so meaning uniform ang electric field at this point. Same lang gyapon dire, uniform. Okay? So same laman yung distance ng mga field points here with respect sa negative Q, as you can see here. So makikita mo yan sa length ng mga electric field vectors nyo. Okay? So yeah, that's it. Now, since we are talking about the relationship between force and electric field, so why not we talk about the direction? Okay? So ano ba talaga yung direction ng force mo with respect to E? So remember, yung E mo is independent of the test charge. So meaning kung yung source charge mo is positive Q, remember, pointing away pa rin yung electric field mo. Kahit ano pa yung test charge, kahit positive ba yung test charge mo, kahit negative pa yung test charge mo, it doesn't matter. Pointing away pa rin yung electric field mo ng positive Q test charge mo. Okay? So here, so I have a test charge positive Q. Okay, so kukunin ko yung field point here. Ito yung field point. So gina-replace na ni Q sub naught. So remember, the field point is where the test charges are usually located para atong makalculate ang or ma-measure na to ang force ma-experience ni Q sub naught. So since positive Q ito, so meaning that iyang electric field na ma-produce is pointing away, so as you can see here. Now if we have a positive Q sub naught, meaning if magputa og test charge at that field point, what will happen is kay since positive ni siya, then therefore iyahang interaction is repulsive, meaning i-repel siya, so same siya og direction ni electric field. Okay, as you can see here, kay since imong Q sub naught is positive, then therefore same sila ang direction ni E, yung force mo. Now how about if yung test charge mo is negative? How about that? Again, yung electric field mo is pointing away. Okay, so independent ito sa test charge mo, hindi siya dependent. So therefore, kay since negative mo yung test charge mo, i-attract siya ni positive Q source charge. So therefore, the force on the Q sub naught and electric field produced by Q is opposite, meaning kay since negative man imong Q sub naught diri. So how about if naatay negative source charge? Okay, so let's answer that. So kung if naatay negative source charge, so I have here a negative source charge, so ito Q, then ito yung field point P ito. Of course, it is pointing, the electric field produced by a negative source charge is pointing towards the charge. So ito yung electric field niya. Now, if I put a test charge at field point P, so magpuput ako ng test charge say positive, what will happen is i-attract man siya, di ba? So meaning same lang din ng direction yung electric field mo tsaka yung force on the test charge. Ito yung Q sub naught, di ba? So based on this expression, so we have Q sub naught E. So same lang yung direction niya. Okay? So if your test charge is positive, but how about if your test charge is negative? Again, yung electric field na produce ni Q is independent, so doon pa rin. So this is the electric field produced by Q. But how about if naatay negative nga test charge? So negative Q sub naught. So since negative ito, so iyang i-repel. So dito opposite lang sila ng direction ni EQ. Okay, so yun lang. Okay? So what I was saying here nga, akong gina-emphasize nga yung electric field nga mapoproduce ni source charge is independent of the test charge. Okay, so independent siya. Okay, so let's start with the calculation. So how to calculate the electric field if we have many charges? So hindi lang isa yung source charge natin, marami na tayong source charge. Okay? So according to the principle of superposition, so just like what we did sa force due to the systems of charges, so meaning i-add mo lang yung vector sum ng electric field produced by the individual source charges. Okay? So we have for example, if meron akong arrangement na ganito, so if I have a triangle arrangement of my charges, so gusto na ko kuhaon ang electric field sa iyahang tunga, midpoint sa triangle. So what will happen is the electric field produced by positive Q ay positive charge, so papunta siya doon kay since pointing away. Your negative 4 is pointing towards, so as you can see here, and your positive 7 is pointing away from the charge. So i-add mo lang yung lahat, and then you can find the total electric field produced by these charges. Okay? So again, if usually kasi yung mga problem natin is two-dimensional at saka in Cartesian coordinate system. Okay? So meron kasi yung different na coordinate system, but we have to stick with Cartesian. Okay? So in two-dimensional, your electric field vector can be expressed using a unit vector, diba? So the electric field produced at field point P, okay, is given by we have EPX, the X component I hat, plus the EPY J hat. Okay? So, the same gap when sa imong electric force, your electric field is also a vector quantity. Now, if sasabihin ng problem, if given sa problem na find also the magnitude and direction of the electric field vector, so you have to take note of these two formula. Okay? So, yun lang. So, sample problems, I will just post the sample problem separately. Okay, so let's just move on to test your understanding. So, an isolated charge point particle produces an electric field with magnitude E at a point 2 meter away. At a point 1 meter from the particle, the magnitude of the field is blank. So, we have to find the magnitude. So, can I go to my Word document? So, if na ko'y isolated, okay, isolated na ko na point, so, yung ma-produce daw ko no, at say at 0.2 meters, so is E daw. Okay, so I have here a charge point particle, so wala siya nag-ingon nga unsa nga field, so 2 meters daw iyang ma-produce here. So how about if naa siya 1 meter? So we have to expect na dako siya ang electric field. So, ang electric field na produce dito is E, na yung magnitude na E. How about this one? So, we have to expect na greater siya kasi nidool man siya sa imuhang source charge. Okay, so but let's see. So, we have E at 2 meters is actually equal to K Q over R squared. Or, ano to? So, parang 2 meters, so away from the magnitude of the field is, so let's answer this one. So paano to? So we have 2 meters, so we have R squared here, so electric field at 2 meters. But how about not electric field at 1 meter? Okay, so this is like K Q over R squared. So parang ano lang natin to, we have to get the parang ratio lang para makita natin yung relationship nila. So we have E of 2 meters divided by E of 1 meters. So we have to cancel out KQ kasi matangtang naman siya tanan, okay? So you have 1 over R2 squared divided by 1 over R1 squared. So, your R2 is 2 meters, so parang 1/4. And your R squared is 1 meter. So, 1 over 1 squared, that is 1. So, parang 1 divided by 1 is 1. So, 1/4 divided by 1 is 1/4. So, the expression E 2 meters divided by E 1 meter is equal to 1/4. Then therefore, yung relationship ng ano mo ng the electric field at point, say 0.1 is we have E at 1 centimeter is 4 times E at 2 centimeter. So 4 times. So, 'di ba ang laki niya? Okay, so 4 times siya. Okay, so as expected kasi nagpaduol naman ta sa charge. So true or false? As used in the definition of electric field, a test charge must be an electron. So false, wala tayong sinasabi na ganyan dapat ang test charge. A test charge has charge of magnitude 1 coulomb. So false again. So hindi tayo nag-specify na ano ang amount ng charge dapat ng test charge. Okay? So any test charge, so any sign of charge, any amount of charge, pwede siya maging test charge. Okay? So, next, understanding. So, experimenter A uses Q sub naught as test charge, while experimenter B uses negative Q sub naught, ay 2 Q sub naught, to measure an electric field produced by stationary charges. What can you conclude from the measured electric field by experimenter A and experimenter B? So, sa experimenter A, nagamit siya og Q sub naught as test charge niya. Experimenter B, nagamit siya og negative 2 Q sub naught. So, unsa man makonclude nato, measure and produced by stationary charges. So, as long as they have the same field point, okay, so no, they have the same field point. Yeah. So, again, independent man lang yung electric field produced by stationary charges sa diba, sa test charge. It doesn't matter kung negative 2 Q sub naught, 3 Q sub naught, or 1 million Q sub naught. So, the measured electric field by experimenter A is the same as the measured electric field by experimenter B. Okay, it doesn't matter sa test charge. Dependent siya. Okay? So, next topic is all about electric field lines. So, electric field lines are actually like a visualization lang siya ng electric field. Kasi, dili naman guna ito makita ang electric field. They are visible. Diba? So, para ma-appreciate po sa mga tao ang electric field, so scientists used a way para malindot po ang topic ng electric field. Okay, so these lines are imaginary. So electric field lines are imaginary. They are just there para ma-visualize yung electric field mo. Okay? So, what are the properties of electric field lines? So, mag-impose tayo ng mga properties. So, first one, electric field lines begin on positive charges and end on negative charges. Okay? So, as you can see here, if na ako'y positive charge dito, if I have a positive charge, so mag-interact siya ng negative charge. So, what will happen is yung positive, yung electric field, iyang suyupon ni negative charge. So, parang si negative para siyang sink. Okay? Tapos si positive is para siya yung wala siya og kanang tig-produce og water. Di ba? Tapos si negative ang sink. Okay? So, how about for isolated positive charges, electric field lines begin from positive charge then to infinity, of course. So, if I have here an isolated positive charge, so walang other charges in space, so kung siya lang, electric field lines begin sa iyaha padulong sa infinity because the electric field lines extend to infinity. Okay? No, kung meron naman tayong isolated negative charges, electric field lines begin from infinity and end on negative charges, di ba? Kasi si negative charge, siya kasi yung parang sink ng mga, parang mo siya tigsuyop sa mga electric field lines ba? Okay? So, yung electric field is nagbigin siya from infinity padulong sa iyaha. Okay? So, mo na ang iyahang ay rules if naatay isolated. Now, next, the lines are drawn uniformly spaced entering or leaving an isolated point charge. Okay? So, lahat ng mga lines natin, as long as meron tayong isolated na point charge, are uniformly spaced. Uniformly spaced sila. Same lang din ito. So, uniformly spaced sila lahat dito sa positive charge at saka sa negative isolated na charge. So, next, near a positive point charge, electric field points away from the charge. So, we already knew that. And of course, for near negative point charge, the electric field points toward the charge. So, you also already knew that. Next, electric field lines are called lines of force. So, the electric field vector is tangent to electric field line. So, what do you mean by this one? Again, sabi ko sa inyo na ang imong electric field is proportional sa imuhang electric force. Diba? So, they are in the same line of interaction. Then, that line of interaction is where the force and the electric field lies. Okay? Dito siya kanang makita nato. So, as you can see here, if meron tayong line of interaction dito, makita natin si E, we have the same line of interaction ni F sub naught. So, therefore, your electric field lines are also called lines of force. Now, the next na property sa electric field lines is field lines do not cross. So, what do you mean by that? So, wala kayo makikita ng mga electric field nga nag-cross. Okay? So, if may ever nga meron na ay nag-cross, what will happen is, the only reason nga na ay nag-cross is if at that point, kay naa siya two electric field nga kuan, two components of electric field. So, for example, na ako'y electric field here, diba? So, naa kay dapat two kanang components of electric field E. So, si E1 and E2 are components of your electric field vector E. Same lang yapon here. If I have E prime, your E2 prime and E1 prime are the components of your E prime at field point P prime. Okay? So, next one. So, wala na ko naingon ang electric field vector is tangent to the electric field lines. Now, electric field lines are imaginary lines. Ang electric field vector gid, which is the true electric field, is tangent to the electric field line. So, meaning, if I have here a point P, so ang imong electric field vector is always tangent. So, tangent intersecting only at one point. Same gyapon sa field point P prime. So, mga tangent sila lahat sa field lines yung true electric field vector mo. Okay? So, another one is the density of the lines is always proportional to the magnitude of the field. Okay? So, if daghan kaayo og mga electric field lines diha nga point, meaning mas kusog ang yang electric field is kusog. Okay? Or dako siya electric field. Now, if gamay ra gani ang electric field lines diha, then hinay po ding electric field diha at that point. For example, sa atong illustration, natay point B and point A. Now, since your point A kay wala man ka siya electric field, meaning ang makuha nimo nga electric field diri is less than the field point na makuha nimo sa point B. Kasi si point B, marami kasi siyang daghan magud siya mga lines diri from the word density. So, daghan og lines. Okay, the denser the lines, the stronger the electric field, or the stronger the electric field. So, next, the number of lines leaving or entering a charge is proportional to the magnitude of the charge. So, so proportional siya sa amount of charge. For example, meron akong positive 16Q. So, meaning, if naa kay 16 lines na mogawas ni 16Q, then naa kay negative 4Q again, so upat ra ang mo sulod ni negative 4Q. So, meaning that for every 16 lines leaving the positive 16Q, naarang kay 4 lines na enters ni negative 4Q. So, that is why proportional siya sa amount of charge. Okay? So, next is, at larger distances, the field lines are equally spaced as if they come from a single point charge which is equal to net charge of the system. So ito na yung sinasabi ko na kan. So, if mo palayo ta sa atong charge nga naay net charge, meaning the net charge is not equal to 0. So, if I have here 3Q minus Q. So, kung mapaduol ta, makita na ginato nga naay 3Q og negative Q nga ga-interact. Okay? Now, kung magpalayo kita layo ta aning duha ka charges nga ga-interact, ato lang makita nga field lines sa larger distance is actually the field lines produced by the net charge of the system. So, unsa may total charge sa system? So, that is positive 2Q. So, ato makita day sa layo is actually field lines by the positive 2Q. So, not the field lines nga nag-interact sa 3Q negative Q. Okay? So, muna siya. Okay, so we are done with electric field lines. So let's move on to electric dipoles. So what are electric dipoles? So electric dipoles is a pair of charges na naay same magnitude but of different sign. So suppose I have negative Q and positive Q, so these are electric dipoles kasi meron siyang same magnitude Q and Q then but of different signs. So for example, meron akong so suppose I have here like positive 2Q and negative 2Q. So these are dipoles. How about this one? Negative Q and positive 3Q. So these are not dipoles. So dipoles are the same sign but of different sign but of the same magnitude. Okay? So I have to talk about dipole kasi lahi man gud ilang properties sa other charges. Okay? So sa other pair of charges. So suppose I have a dipole system like this one, tapos gusto ko kukunin yung electric field at point P here. Again, the electric field at point P is not equal to the electric field at point P here, so mag-iba-iba siya. So I just put it here for convenience lang, so para makita nyo kung anong kung sa properties sa imong electric dipole. Okay, so let's start. So I have here a x-axis system. So again, I will just put the dipoles symmetric lang siya with respect sa imuhang y-axis. So I have here the negative Q and this one is the positive Q. So here meron siyang distance na 2a. So since symmetric man siya sa imong y-axis, so therefore this distance is equal to a and this distance is also equal to a. Okay, so I will just get the electric field at point P here. Dili na ko kuha ng field point P, so we can let this one as point distance x from the origin. Okay, so how to get the electric field gani? So we just have to sum all of them. So the electric field at point P is equal to the electric field produced by the negative Q charge plus the electric field produced by the positive Q charge. So the electric field produced by the negative Q charge, okay, so we have K, tapos meron ito yung negative Q, tapos R squared. So ano yung direction niya at field point P? So towards the charge. Ito yung E, the negative Q, tapos yung electric field produced by positive Q is pointing away from the charge. Okay, so here we have a negative Q here. So I will just stick to a positive 1. Okay, so kasi ito yung no. So parang magnitude lang kasi siya to. Okay, so magnitude siya. Tapos we have here the direction is negative I hat. Okay, so walang y component kasi straight line lang siya along x-axis. Then we have here, what is the distance of R? I mean the distance between negative Q and P. So that is just equal to, since ito yung x, tapos here is negative a kasi ito. So we just have to add them. So we have x plus a. So ito yung distance between ni negative Q tsaka ni field point P. So we have here K Q over x plus a squared negative I hat. Okay, So next, how about yung electric field produced by the positive charge? So we have the magnitude, kq over r squared. Tapos yung direction niya is positive I hat kasi it is pointing towards the positive x-axis. Then we have kq, and yung r niya, what is your r? R is the distance between q and p. So ito yung, so the distance here is actually x. Tapos kukunin ko si minus a. So x minus a lang ito. So the distance here is x minus a. So we have x minus a squared, and we have positive I hat. Then adding them, so we have here kq x plus a squared, positive I hat. So I will just put the I hat sa gawas. Okay, so this must be negative, tapos ito yung positive, di ba? X minus a squared, tapos ang labas is I hat. The next, what is simplifying? So we can get this equation na dayon, okay? So we have 4ax kq 4ax divided by x squared minus a squared squared I hat. So what is very good about this property, so using the electric field produced by this electric dipole, is, as you can see, if we are going to move to a larger distance, so meaning when x is greater than the distance nila sa both between the electric dipoles, so meaning p, palayo na to si p, the electric field decays faster. So this means that rather than mo decay siya according sa inverse square law nga 1 over r squared, mo decay siya into 1 over r cubed. So paspas ang iyahang pag decay or paghinay sa imong electric field strength if magpalayo ka sa usa ka system of electric dipole. Okay, so meaning with this we can conclude that if naa kay net charge equal to 0, then this means that ang mong electric field is inversely proportional or inversely proportional to 1 over r cubed. Kasi yung net charge ng electric dipole is equal to 0, di ba? So q, negative q plus positive q is actually 0. So wala siyang net charge. Okay? So yan yung pinaka-important na property ng electric dipole. Then the next one is the application of electric dipole. So why do I include electric dipole? Okay? So ngano unsa man jud na ka siya ka-importante, because usually electric dipole are very important in technology na karon. Okay? So let's start with the torque system. Okay, so torque. So since sa physics 81 nyo is wala kayo nagkuhan ng torque, so I assume nga so torque is actually the rotation of a system at a certain axis of rotation or at a certain point. Okay? So suppose na ako'y dipole nga akong ibutang sa electric field. Okay? So a uniform electric field, so I have here electric field na nag-straight line here, muna siyang electric field. Tapos here, this one, the force exerted by this field on the positive q is going in that direction. Okay? So kasi positive q kasi siya, so that's why they must be on the straight line. I mean, they must be on the same direction. This one, the negative q, the force exerted by E is in opposite kasi negative q. So therefore, wala siyang net force. So what do you mean by that? Kung walang net force, hindi siya mag-move in a straight line. Okay? So di siya mag-move na pa straight line ba? Okay? So di siya mag-move translationally. Pala ng car na move siya in a straight line. So di siya kaning negative and positive will not move together along a straight line kay wala man siya net force. Okay? But naa siya torque. Okay? So naa siya rotation. Okay? So even though wala siyang net force, pero meron naman siyang torque. So that's why the dipole will rotate into direction of the field. Okay? So mag-rotate siya pag ganito in direction sa field. So here, let's start. So the magnitude of the torque using this equation is given by this one. So we have torque is equal to, so denoted by tau, is equal to PE sine of theta, or the theta here is the angle of angle between your E, electric field magnitude, at saka ni P. So you can see here, actually your P is the dipole moment. So the dipole moment, as you can see in chemistry, so naka-remember, dipole moment is actually the unbalanced concentration of charges. Okay? So mag-point ang imuhang dipole moment dito sa from negative to the positive. Okay? So we have here so the dipole moment P, so kuan ang background lang, is given by QL. So P is actually, dipole moment is a vector quantity. Okay? So your Q is like the magnitude of the charge involved. So same naman sila ng magnitude, so Q lang ang nilagay. Then your L is the distance of two charges. So L is again pointing from negative to positive. So same sila ng direction ni dipole moment. Okay? So always na siya, always pointing from negative charge to positive charge. So because of this relationship ni dipole moment, the SI unit of your dipole moment is given by C times meter. So the coulomb times the meter. So ano pala yung yung application ng electric dipoles when it comes to torque. So again, torque, di ba, mag-rotate yung electric dipole mo, okay, in one place, where axis of rotation is probably nandito sa pinaka-center nila, midpoint. So nakikita, kabalo mo sa microwave oven, di ba? So any food na siya water molecules always, di ba? So water molecules are a common example of electric dipoles. So as you can see here, so you have O2 minus, so the oxygen ion and the hydrogen ion. So the electric dipole is pointing from negative to positive. So as you can see here, P. Now, I will not go through deeper about that, but I will just give you some application para ma-appreciate nyo yung torque in electric dipole. So ito na. So tanan nga mga pagkaon nato na ay water molecules. So dili ta makakuha na, di ta maka-argue. Okay? So if ibutang nimong pagkaon sa microwave oven, so kung pila lang ka minutes, 'di ba? In just a minute, inyuhang pagkaon kay mainit. Okay? So kanang imuhang pag-rotate sa imong electric dipole is actually the cause nganong niinit ang imong pagkaon in just a matter of second. Okay? So ganun yung application ni electric dipole. Okay? So I think mo na siya. And then we have the sample problems which will be posted separately in a video. So ito, so I will just post it sa ating VLE site yung mga assignment.